Hey everyone, my name is Dan Boatman, and today I'm going to be talking to you about random number generation, specifically in communications. So here's an overview of what we're going to cover today. First, to talk about random number generation, we'll need to define terms like random and random number sequences. Then we can dive into some of the history of random number generation. Then we can talk about the differences between pseudo-random and truly random, and some of the types and techniques of each of those. And finally, we will delve into random numbers and their role in communications. And as you can see here, some of the topics we'll talk about today have been covered by other student presentations, but random numbers really play a vital role in what they've already talked to us about. So first, to talk about random number generation, we must define what random truly is. And even though this seems fairly straightforward, it really comes into play further down the road. So, random really at its core means non-deterministic and unpredictable. So if you think about rolling dice or flipping a coin, there's no way to determine the outcome of those events until they've actually happened. So, a random number sequence is essentially putting several of these random numbers together into a sequence. This has two parameters. First off, it must be uniformly distributed over all possible values. So if you think about the dice again, this basically means it must be distributed over 1 through 6. Second, each number in the sequence must be independent of the other numbers. A random number generation is simply the creation of a random number sequence. So now we can talk about some of the history behind random number generation. This is by no means a comprehensive history, but it does hit some of the main events. So for probably a few thousand years, the only way that random numbers could actually be generated came in the form of things like rolling dice or flipping coins or things along those lines. But in the 1940s, John von Neumann developed the first pseudo-random number generator. He used an algorithm called the middle square method. So basically, you start with an initial value, and to get your value, you square that number and then take the middle numbers from the final result. So if you start with 11, you would square it and get 121, and then you take the middle value, so your final number is 2. However, this algorithm really had some shortcomings. So if you think about if 0 is your initial value, then you end up with 0 in the end too. So despite its flaws, it was a very big jump from what we had previously. Around the same time, the Rand Corporation published a book called A Million Random Digits with 100,000 Normal Deviates. Around the same time that von Neumann developed his algorithm, they developed a machine that generated truly random numbers. I believe they used electrical impulses to get these numbers. So basically, they spent a few years generating these random numbers, verifying that they actually were random, and then collected them into this book. And so for a very long time, this book was the easiest way to have true random numbers for anyone who really needed them. So they actually republished this book in 2001, and you can still buy it on Amazon today. And I found out during my research that people love to leave hilarious reviews on this book. So if you're ever really bored, go check that out. So for a very long time, very similar things were happening where algorithms were developed or machines were developed to determine these random numbers. But there was a clear jump in the 1990s. So with the internet, secure socket layer protocols were introduced, basically as a way for your computer to communicate with the server. And so this created a very high demand for random number generators to keep security within these communications. And so around this time, there's a really high demand for random number generators, and one pseudo-random number generation algorithm called the Mersenne twistor was introduced. And this algorithm is still the most widely used software pseudo-random number generator today. although there have been others developed since then as well. So I talked a lot about pseudo-random and true random so far throughout this presentation, but it's really important that we know the differences between those two. So first, true random is random numbers that are truly non-deterministic. So if you think about rolling dice or flipping coins, it's things like that. So these are usually generated through physical phenomena, and they're generally a little bit slower and harder to come across. So one form of true random number generation I actually found out about during my research was in the 1990s. A company set up a webcam that was watching a lava lamp, and they would detect changes from the lava lamp just being turned on, and that's how they generated their random numbers. So on the other hand, pseudo-random is generally used in things like computers, which means that it's deterministic. These numbers are generated via algorithms that require an initial value to actually get the random numbers. The plus side to this is that it's very fast and easy to implement. So we'll talk a little bit more about each of these more in depth. So pseudo-random is often used by computers, like I said. So computers are inherently deterministic and therefore cannot create something that is non-deterministic. However, if using a complex algorithm, computers can closely approximate true randomness. So this provides a fast, inexpensive, and easy to implement alternative to generating true random numbers. These algorithms generally require an initial or seed value. I know in my computer science classes, there's a function called srand, and that uses the current time to generate the seed value for random numbers. So if algorithms are not sophisticated enough, random number sequences are prone to vulnerability. Basically, the algorithm can be cracked and traced back to the original values. So there are a few various types of pseudo-random number generators. Like I talked about in the history section, there's the Mersenne twistor. There's also linear congruential pseudo-random number generators. And finally, and more recently, cryptographically secure pseudo-random number generators have been developed. And that plays a large role in encryption. So there are a few advantages and disadvantages to using pseudo-random number generators. Some of the advantages are that it is fast, it is inexpensive, it's easy to implement, especially in things like computers, and some algorithms can very effectively approximate true random number generation. However, no matter how close these approximations are, pseudo-random codes can never be truly random. They generally require an initial value, like I said before, which makes them potentially vulnerable or prone to be attacked. On the other hand, true random number generators are generated through means that are inherently non-deterministic. So a lot of times this takes the form of physical phenomena or even quantum mechanics too. So a few different examples of how these numbers are generated is through atmospheric changes, thermal noise, quantum mechanics, which I believe Dr. Blair has random number generators that use quantum mechanics to generate the numbers. And then, like I said earlier, even lava lamps can be used to generate these numbers. They often require hardware to actually detect these changes, but the benefit there is that there's no way to trace back through an algorithm or anything like that to determine where the sequence came from. It is truly random at its core. So that really is the biggest advantage to true random number generation, is that there is no algorithm, there is no initial value. It is truly random, which makes it theoretically a lot more secure. The disadvantages there are that true random number generation takes time, it's more expensive, and generally requires hardware to actually implement. So there are several applications for random number generation in communications. So the four that we're going to talk about today are direct sequence spread spectrum, frequency hopping, encryption, and secure communications in general. So first is direct sequence spread spectrum, which Jackson talked about in his presentation. So I won't go into too much detail about what it is, but I will talk about how random numbers play a role in that. So it's basically, it's a transmission method for wireless local area networks. So random numbers come into this because you multiply your data signal with a pseudo-random code. Now this code is only known by the transmitter and receiver, and it's generally much faster than the signal, so that when you multiply them together, it spreads out your data signal across a much larger spectrum. So this makes it much more secure and harder to intercept. So then this transmission can then be decoded and recovered by the receiver. Although it requires a higher bandwidth, it allows for secure communication due to this pseudo-random sequence that you're multiplying it with. So very similarly, frequency hopping is another spread spectrum technique. However, instead of spreading across a single frequency, you essentially use a pseudo-random code to force your signal to hop between different frequencies. So this code, again, is only known by the transmitter and the receiver. So since the receiver knows this code as well, it's able to decode the signal across multiple frequencies. So frequency hopping really allows for very secure communication. It's very hard to intercept. It's also robust against interference. And this is used in Bluetooth technology. So random numbers really play a vital role in frequency hopping as well. Encryption is another large area where random numbers play a vital role. And Joe talked quite a bit about encryption and several of the modern methods that are still used. So again, I'm not going to go into depth on the various methods and how they work, but I will talk about how the random numbers play a role in this. So obviously there's several types and techniques for encryption, and generally they're dependent upon pseudo-random encryption keys and algorithms. So the security of the encryption is really directly correlated with the strength of the pseudo-random number that you're generating. So one example that we'll talk about is RSA encryption. So this is an encryption method used for secure data transmission. And the encryption key is essentially the product of two very large prime numbers. The way that random numbers play a role in this is that the prime numbers have to be selected at random and then multiplied together. And that's really what provides the security in the encryption key itself. So the security of the transmission is entirely dependent on how randomly those two prime numbers are chosen. So between those three topics, I talked about secure communications a lot, and that is really what random number generation provides in communications. So random number generation is vital for secure communications, and many communication protocols, like we just talked about, utilize random number sequences in order to encrypt data that's being transmitted. And the quality of these random number sequences and the quality of any algorithms that are used or any way to come across these random numbers really determines the security of the transmission. So random numbers play a really vital role in the security of communications that we've been talking about all semester. So pseudo-random number generators are adequately secure if initial values are well seeded and algorithms are complex. Basically, you don't want anyone to be able to trace back through your algorithm to the initial value and crack the code, basically. So the pseudo-random number generators used today are generally very secure, even though some of the very first ones, like the middle square method that we talked about, were not so. They've really developed over time very well. So in summary, we talked about the definition of random number generation, as well as random number sequences. We talked about some of the history behind random number generation. We talked about the differences between pseudo-random and truly random numbers, and some types and techniques of each of those. And finally, we talked about random numbers in communication, specifically regarding direct sequence spread spectrum, frequency hopping, encryption, and secure communication in general. And these are my sources. Thank you so much for your time.